The Projectile Motion Simulation is an interactive educational tool designed to help students investigate and understand the factors that affect a projectile's trajectory. By providing a hands-on approach to exploring the principles of projectile motion, the simulation offers a comprehensive learning experience that covers fundamental concepts in physics. The simulation allows students to adjust various parameters, such as angle, height, initial speed, and air resistance, and observe their effects on the projectile's trajectory, velocity, and acceleration. Additionally, students can view the drag and gravitational forces in a free body diagram and explore the relationship between the drag force and velocity. The projectile motion simulation allows students to investigate how the angle, height, and initial speed of a projectile affect its trajectory. By adjusting these parameters, students can observe how the path of the projectile changes. For example, increasing the launch angle can result in a higher trajectory, while increasing the initial speed can result in a longer range. This interactive feature helps students understand the relationship between these factors and the projectile's motion. The simulation also allows students to explore the effects of air resistance on the projectile's trajectory. Air resistance is a force that opposes the motion of the projectile through the air. By adjusting the air resistance, students can observe how it affects the projectile's velocity and acceleration. For example, increasing the air resistance can result in a shorter range and a slower velocity. This feature helps students understand the impact of air resistance on projectile motion. The simulation provides a free body diagram that allows students to view the drag and gravitational forces acting on the projectile. The free body diagram is a graphical representation of all the forces acting on an object, including the direction and magnitude of each force. By observing the drag and gravitational forces in the free body diagram, students can gain a deeper understanding of the forces that govern the projectile's motion. The simulation allows students to explore how the velocity and acceleration of the projectile are affected by air resistance. By adjusting the air resistance, students can observe how the drag force changes and how it affects the projectile's motion. For example, increasing the air resistance can result in a greater drag force, which in turn affects the projectile's velocity and acceleration. This feature helps students understand the relationship between the drag force and the projectile's motion. The simulation allows students to determine the factors that affect the drag force and observe the relationship between the drag force and the velocity of the projectile. The drag force is proportional to the square of the velocity of the projectile, meaning that as the velocity increases, the drag force increases quadratically. By adjusting the velocity of the projectile, students can observe how the drag force changes and understand the relationship between these two variables. Students can also explore other factors that affect the drag force, such as the shape and size of the projectile. The drag force is influenced by the cross-sectional area of the projectile and its drag coefficient, which is a measure of the projectile's aerodynamic efficiency. By adjusting these parameters, students can observe how the drag force changes and understand the factors that affect it. The simulation allows students to adjust various parameters of the projectile, such as its mass, shape, and size, and observe their effects on the projectile's trajectory. By manipulating these parameters, students can explore how they affect the projectile's motion and gain a deeper understanding of the principles governing projectile motion. The simulation also allows students to investigate the influence of gravity on the projectile's trajectory. Gravity is the force that pulls the projectile towards the Earth's surface. By adjusting the gravitational force, students can observe how it affects the projectile's motion. For example, increasing the gravitational force can result in a shorter range and a faster descent. This feature helps students understand the role of gravity in projectile motion. The simulation provides an interactive platform where students can actively engage with the concepts of projectile motion. By adjusting various parameters and observing the results, students can gain a deeper understanding of the principles governing projectile motion. The visual nature of the simulation makes abstract concepts more tangible. Students can observe the projectile's trajectory, velocity, and acceleration in real time, helping them to grasp complex ideas more easily. The simulation offers immediate feedback, allowing students to see the results of their adjustments instantly. This helps correct misunderstandings quickly and reinforces learning through trial and error. The simulation covers a wide range of topics related to projectile motion, including the effects of angle, height, initial speed, air resistance, drag force, and gravity. This comprehensive approach helps students gain a holistic understanding of the principles of projectile motion and their applications in various fields. The projectile motion simulation is a valuable tool for teaching and learning about the principles of projectile motion. By providing an interactive, visual, and comprehensive platform, it helps students understand the factors that affect a projectile's trajectory, such as angle, height, initial speed, and air resistance. The simulation allows students to view the drag and gravitational forces in a free body diagram, explore the relationship between the drag force and velocity, and investigate the influence of gravity. Whether used in a classroom setting or for individual study, this simulation can significantly enhance the learning experience and build a strong foundation in physics. Through exploration and experimentation, students can gain a deeper appreciation for the complex and fascinating world of projectile motion and its applications in various scientific and engineering fields.